Chapter 7, Section 1, Slope-Intercept Form, Apprentice level. Identifying the slope. So first we want to complete each table of values and then plot each function. So here we have an equation, and we know from a technique that I showed you in the previous chapter, we can just look at this equation and we know that it is linear. So we know this is going to give us a straight line. And I've actually started the table of values for you. I've actually chosen the x values to use. There's nothing special about them. That's just what I chose. So one by one, we are going to substitute these x values into this equation here. We're going to get our y value and then just plot our dots. Pretty simple. So -2. So -2 times -2, that becomes +4. Then we subtract 1, that gives us 3. Okay. Now x is -1. So this is -2 times -1. That becomes +2. Subtract 1 is 1. Okay. And we can continue all the way down. So that's going to give us -1. It's going to give us -3. And that we get -5. Right? So we now have 5 ordered pairs. So let's plot these dots. So that goes here, this one there, and there. And I think already you can see this is a straight line. Perfect. All right. So we can connect this, of course, because we could have used any point in between. That's all right. Not perfect with this machine, but there we go. All right, so that's the first one. All right, for the next one, same idea. The only thing that makes it seem a little bit more challenging is that we have to work with a fraction here. But you should be comfortable working with basic fractions. And when you're multiplying a number by, say, 3/2, really what that is you're just multiplying by 3, and then you're dividing by 2. Okay? So when you're dividing by 2, it would be nice if the result that we're working with is already even. Okay? That way when you divide by 2, we don't have any decimals to work with. And we saw that in the previous chapter. So notice here actually in my table of values, I've already chosen only even values of x, so that when we divide by 2, we don't have any decimals. All right, so for this one I'll actually show the work. So x is -4. So we're just going to substitute that in there. So we get 1 plus 3/2. Now, when x is in the middle here, you can leave it there, or you can actually multiply it into the numerator, but not the denominator. It's up to you. I'll leave it in the middle. Doesn't make a difference. There we go. Okay. Continue to work down, so we got 1. Now, it's up to you. You can multiply 3 times -4, which is -12, and then divide by 2. That would give us -6. Okay, you can do it that way. Or we can actually reduce as we go, because -4 divided by 2 is actually -2/1. Okay, and any integer has an invisible 1 underneath it anyway. You don't have to write that. So we'll get the same result. So the 1's in the denominator don't do anything. So we have +3 times -2. Well, we get -6. So that gives us -5. There we go. All right. So you don't have to do this, but I'm just going to do this same part again. I'm actually going to show you what I meant before by writing the number in the denominator. This is totally optional, but this is just to give you options. So the x can go in the numerator. So we're dealing with -4, so I'm just going to put that there. Okay. So you get 1. Now let's work what this is. So we have 3 times -4, which is -12, and then we're dividing by 2. So that becomes -6. So this is plus, I'll put this in brackets, doesn't matter. There we go. But you should know that 1 plus -6 is just 1. Take away 6. And we get the exact same answer as before. So whatever technique you choose to work with is totally fine. All right, Let's try x is equal to negative 2. All right. Do that here. So we have 1 plus 3 over 2, and we have x. That's now negative 2. Okay. So let's work this out. This is 1. And we can simplify all this stuff here. So we know that negative 2 divided by 2, that is going to simplify, because that's going to give us negative 1 over 1. Okay. You can write the invisible 1 under here if you want, but it doesn't do anything. All right. So we have positive 3 times negative 1, that is negative 3, over 1, which again we don't need, so we just write negative 3. And we get negative 2. So there we go. Okay. Now, since we already know that this is linear, hence we're going to get a straight line, instead of using this technique for the rest of these numbers, which take a little time, I'm going to apply the technique that we used in the previous section when we were trying to identify linear relations. So notice how x is always increasing by 2. Okay, and y from negative 5 to negative 2, that's an increase of positive 3. Okay, so that pattern has to remain consistent if it's linear. So just keep adding 3 each time. So that gives us 1, 4, and 7. There we go. So let's plot these points now. Negative 4, negative 5, negative 2, negative 2, 0, and 1, 2, and 2, 4, 7. Whoop. That's 4. Wrong spot. There. All right. And we have a straight line. So let's do that. There we go. So there's our 2 lines. For the second function, why is it advantageous to use even numbers when plotting points by hand? So I did discuss this earlier, but let's put it down here. It's easier to divide even numbers by 2. And we were dividing by 2 because in that fraction we were multiplying by 3/2. So that's the same as multiplying by 3 and then dividing by 2. All right. Now it says for each function use any 2 points to determine the slope. Okay. So this is something that you should be familiar with. So from the table of values, each table of values we have 5 points. Choose any 2 of them you want. It totally doesn't matter. So for the first one, that was, I'm just going to write it down here, that was y equals negative 2x minus 1. The 2 points I'm going to use the first one. So that is negative 2 and 3. And I'll use the fourth one. You don't have to choose these points in particular. So let's work it out. Now we know that slope, okay, is rise over run, or delta y over delta x. Now it's your choice. You can use the formula, or you can simply count squares from the line. Okay. I'll use the formula for this one. Why not? So which one is y2, which one's y1? It actually doesn't matter as long as you're consistent. So I'll just make note. I'll make this one x1, y1, and I'll make this one x2, y2. Okay? All right. So we want y2 minus y1. So that is negative 3 minus, and y1 is 3. Over x2 minus x1, remember from our formula? So that is 1 minus, and x1 is negative 2, so I'm subtracting a negative. All right, So we have our slope. We just need to simplify. So this numerator is negative 6. Okay. And we have 1 take away negative 2. That's the same as 1 plus 2. That's positive 3. And of course, this is reducible quite nicely. I'll work to the right just once because I'm running out of room. Negative 2. All right. All right. And for the next one, I'll just write it down. That was y equals 1 plus 3 halves x. Remember, the x can go in the numerator too if you like. All right, I'm just going to write down which points I'm going to use. So I'm going to use the third and the fourth point on the list. So that is 0, 1, and 2, 4. Okay. Now it doesn't matter which one you choose to be x2, y2, whatever, as long as you're consistent. So why not? I'll flip these around. So I make that x1. Therefore, this has to be y1. Okay, that's what I mean by being consistent. Is you can't make this one x1 and this one y2. You don't want to do that. Got to keep your points together. So that's x2 and this one's y2. All right. Slope. Again, you can count squares, rise over run, or you can use the formula, which I'll use. So y2 minus y1, that is 1, take away 4, over 0 minus 2. Okay, so 1 take away 4 is negative 3. 0 take away 2 is negative 2. Okay. This fraction is not reducible. However, a negative divided by a negative, well, we just get a positive answer in the end. Okay. So the best I can do is 3 over 2. So the slope of that is 3 over 2, or 1.5. All right, what do you notice about the two slopes? Hint, look at the two original equations. Now what you may have already noticed is that the slope here, say negative 2, that number actually appears in the original equation right here. Same goes for this one. The slope was 3 over 2, but that's 3 over 2 right there. It appeared in the original equation. And in both cases, it was the number in front of the x. It was what was multiplying x. So it had nothing to do with this number here, the 1 and the negative 1. So perhaps in the future, if we see an equation like this, we can just read it and tell what the slope is without actually having to pick points and plot them and calculate them directly. So what do you notice about the two slopes? Well, the slope is the number multiplying x. All right. Well, let's apply this technique. So below it says, without graphing, quickly determine the slope of each linear function. So before, if I gave something like this to you, you'd have to graph it. Maybe use a table of values. You pick 2 points, or you count squares, and you find the slope. Well, that takes a while. Okay. Well, we have y equals 4x plus 7. Well, the number multiplying the x is 4. Okay. So therefore, the slope is 4, or 4 over 1, same thing. All right. Let's go down. Y equals 9 minus 3/4 times x. All right. Well, the number multiplying the x was not 3/4, negative 3/4. Remember, we have to include that sign. So the slope is negative 3/4. So notice how it doesn't matter the order that I've written the terms. I'm looking for the number multiplying the x. Over here, the number multiplying x is negative 5. See, it's pretty easy. Next, we have x. There doesn't appear to be a number there. We just have a negative sign. Well, in this case, there is an invisible 1 hiding in here. We just don't usually write it. So now we can see that it is negative 1. So already we should be able to visualize that this graph here with a slope of 4 from left to right is going up. These three that we've done, these all have negative slopes. Therefore, from left to right, they are going down. Next, the number multiplying x is 1/2. Therefore, my rise over run is 1 over 2. So from point to point, you can go up 1, right 2, up 1, right 2. And the next one, the slope is 6. Okay. So you see how easy it is to identify the slope of an equation that looks like this. Okay. Now the title of this particular lesson is Slope-Intercept Form. So I'm just going to write that down here. If you have an equation that looks like this, y equals, you have some number m multiplying x, and then you have some other number here tacked on. We'll just call it b. Okay. You notice that each of these 6 equations are of this form. Okay. These two terms here might be flipped around, but in this case, the number multiplying x, that represents the slope. Okay. We're going to learn about what this b represents here, but I'm not going to deal with that right now. So if you see an equation of this form, the number multiplying x, which we'll call m, that is the slope. So m is the